let's say there's a soccer ball and it is kicked at some initial angle with respect to the ground. So let's say that angle is gamma, and the soccer ball, we'll say, has radius r. And it's launched with initial speed, the initial, and it gets kicked. So it's moving, but it's also spinning with constant rotational speed omega. And acceleration due to gravity exists. So given initial launch speed and angle, as well as radius of the ball and its angular velocity, which we're going to say is constant, then we need to find the velocity and acceleration of a point P on the ball. So let's put some numbers into here. Initial velocity will be 10 meters per second. Initial kick angle is 30 degrees. Radius of the soccer ball will be 0.1 meter. And then angular, we'll say that is 20 radians per second. All right, so steps for this. First step is find the general planar motion equation for velocity. And then 2, general planar motion equation for acceleration. For these, we'll need to know the r vectors and assign in between points. So let's say this point, the center of the ball, we'll call that C. Because we know velocity of C, it's this initial velocity. So the velocity of the point is going to be velocity of C plus velocity of P with respect to C. So for 1, velocity of P equals velocity of C plus velocity of P with respect to C. So velocity of C, well, we know that from these components, this will be V initial cosine of gamma I plus V initial sine gamma in the J. And then velocity of P with respect to C is going to be omega cross with RP with respect to C. Well, we need to know what is RP with respect to C. So we need to know the angle of the ball, and we'll assume that the ball starts out with P straight horizontal. So RP with respect to C is going to be, we need to know this angle, that's angle theta. Well, by integration, let's say this is, let's see, theta equals omega t. We know that. So this here Then we'll have RP with respect to C is going to be, let's see, we have I, J, K, 0, 0, omega. And then RP with respect to C is going to be R cosine omega t, R sine omega t, and 0. But if we look at angular velocity, okay, it's going down. It's going the other way. So the J is actually going to be negative because it's spinning counterclockwise. So this part will have I hat times R sine omega t omega, and then minus J hat times R omega cosine omega t, and that becomes positive. So BP equals V initial cosine gamma plus R omega sine omega t in the I hat plus V initial sine gamma plus R omega cosine of omega t in the J hat. But actually, since this is changing with time, V initial, or V is not always going to be V initial, and gamma is not always going to stay the same. So really, this part, we'll have to use those projectile motion formulas. V y equals V initial sine gamma minus GT, Vx equals V initial cosine gamma. So here, V initial cosine gamma, that's good. Here we have V initial sine gamma minus GT, needs to be in there. So this is the formula for the velocity of that point. So if we put in the numbers, Vp equals 10 times cosine 30, which is going to be 5 square root 3, plus 2 sine of 20t I hat, plus the initial sine gamma, which is 5 minus 9.81 t, plus 2 cosine omega t j hat. So this is as a function of time. If there was a specific time that we wanted, then we could plug it into here. Now, acceleration. Equals acceleration of c plus acceleration of p with respect to c. So this is going to be acceleration of c, which we know is going to be negative g in the j hat, plus omega dot cross r plus omega cross r but we know omega is constant. That was given, so we get rid of this part. And then we do this cross product. This is going to equal I, J, k, 0, 0, omega, and then the omega cross r, which we got up here, and that is r omega sine, r omega cosine 0. And that equals I hat times negative r omega squared cosine omega t minus j hat times, this becomes a positive, r omega squared sine omega t So then we put all those together and we get A, P equals negative 9.81 J hat minus R times omega squared is 40 cosine omega t I hat plus 40 sine omega t j hat. So AP equals I hat times negative 40 cosine omega t plus j hat negative 9.81 plus 40 sine omega t. This will be in meters per second squared. So summary of what we did for this problem. First, we figured out what our theta was and our positions. And then we just used the general planar motion equation to figure out velocity and acceleration of the point.